A coin is projected at an angle of 53 degrees above the horizontal from a point 15 meters above the ground level. It reaches the ground at a horizontal distance of 40 meters from the launch point. Calculate the time it was in the air, the velocity with which the coin was projected. If you want to answer questions properly in physics, make sure first you have got at least a picture of what you are dealing with. Say here is the point where we had to throw this coin from, and we've been told that 15 meters above the ground. So from the point at which you are throwing, there is 15 meters there, right? That is 15 meters. And you had to project this stone at an angle of 53 degrees. So it had to go up and then coming to drop like that. This is 53. Another thing we've been told is that the horizontal distance it had to cover from the point of the launch is 40. So we've been given the range that is a 40 meters. So what is the time it spent in the air? So we know that the time of flight is given by ut plus half gt squared. Again, you can use two formulas, but I'm not going to use both of them. I'll just use this simple one. The height is 15. Now, please always attach a negative there. In case you are wondering why we are attaching a negative, please watch the previous video and you are going to be able to see why we are attaching a negative. U, that is the initial velocity in the y direction, is given by the velocity. Now, we don't know the velocity, right? Yeah, we don't know the velocity. It's supposed to be u, which is the initial velocity. Sin theta, the angle is 53. And then we're now supposed to multiply this by the time. Because the projector first went upwards, so we're going to have minus g. G is going to be negative t squared. But as you can see, we have got two variables here, u and t, so there's no way we can solve this equation. But wait, this question is actually way simple. So to find part 1, it is way simple because we've been given the range. Remember that range is equal to velocity in the x times time, right? So velocity index times time. So the range is 40. Velocity index is given by initial velocity. Instead of me using u, we know we are talking with of initial velocity. Let me just use v. Others use for initial velocity, they'll use v or to mean u, which is the initial velocity. But I'm not used to writing v or. I feel the terms will be just a lot. Okay, I'll just put v to mean initial velocity. I'm just supposed to be cos 53. And then we're supposed to multiply that by the time t. And then here we have got 40 is equal to cos 53 is going to be 0.601815, and then we are going to have this v and to multiply with a t. I'll divide both sides by 0.6151815. So we're going to remain with only vt. So vt is going to be, so 40 divided by 0.601815, and that is going to give us 66.4656. Let's say this is equation 1. I can finish simplifying this one here. So be negative 15 is equal to sine of 53 is going to give us a 0.79863. Remember, I've got a v to multiply with a t, so that will be vt, and then minus half times 9.8, that will be 4.9 t squared. Can you see we have got vt here and we have got vt here? So where there is vt, I'm going to put 66. So this will become negative 15 is equal to 0.79863, and then we'll put 66.4656 there minus 4.9 t squared. So be negative 15 is equal to, so we'll multiply this number that we have here. Actually, I can make it easy. Let me do something so that we can move quickly. I'll get this one which has got a t, take it the other side, becomes positive 4.9 t squared. That will be 0.79863 multiplied by 66.4656. I'll take 15 the other side, it becomes positive 15. So this will be 4.9 t squared is equal to, I'll just punch this over the other side together on the calculator, multiply and then add with the 15. That is going to give us a 68.081799286. Divide by 4.9, that will be t squared is equal to 13.89424. And then square root both sides. I'm going to find that t is going to be equal to 3.727 seconds. So that's the time of flight. And then the velocity with which the coin was projected. Now to find the velocity with which the coin was projected, that's the initial velocity here. You can use any one of these equations. You can just pick it from here to be easy, right? You can see that equation. That is 40 is equal to that. Or you can actually pick it from here. Vt is equal to 66. So that will be part 2. I'll just now make V the subject formula. So V is equal to 66.4656 over T. And the T is what we found as 3.7274. Therefore, V is going to be equal to 17.828 meters per second.